Hello, welcome to my YouTube channel. Today I'm solving my puzzle, Return of the Birds. The rules, ordinary sudoku rules. So the digits 1 through 9 in every row, every column, and every 3 by 3 box. The pair of digits across each white dot differ by 1. So these white dots here, the digits across those dots differ by 1. And the ornithologically adjacent rule, birds indicate ratios. Any pair of digits across a bird are in the same ratio to each other, as are all pairs of digits across that type of bird. Different birds might share a ratio, but different ratios do not share a bird, and not all birds are given. So across this flamingo, that might be a 1 to 2 ratio, then the digits across this flamingo and this flamingo are also in a 1 to 2 ratio. And a different bird, like a turkey, might also be in a 1 to 2 ratio, but no other flamingo is anything but a 1 to 2 ratio. Those are the rules. If you want to try the puzzle without my help, go pause the video and go try it. Come on back and let me know how you did. First thing I do in this puzzle is I locate where my 5s and 7s are. We know that a 5 and a 7 can only go on a bird if it goes on every bird of that type, because a 5 with any digit or a 7 with any digit forms a unique ratio that has no equal or no, equivalent ratio, equivalent fraction with digits from 1 to 9. So 5 and 7 cannot be on any bird where there are 4 cells in a row or in a column, these doves, or in a box, these swans. And if they're not on a swan or a flamingo in one bird, they're not on any of those birds. There's no 5 or 7 on any swan or flamingo. I'm going to mark those yellow so I can see them. There are 3 hen cells in that box, or chickens, so there's no 5 or 7 on any of the chickens. Because if there were a 5 or a 7, say a 5-3 there would need a 5-3 here, and neither a 5 or a 3 could be there. And there's any digit you mix with a 5 or a 7 is going to have a unique ratio like that. The turkey here, there's 3 turkey cells in this column, so no turkeys. There are 3 owl cells in this box, so no owls. There are 3 duck cells in that row, so no ducks. And there are, okay, that's it. I've done it. Now, those are the cells that cannot be 5 or 7, and they are marked yellow. Anywhere we have 7 yellow cells in a row, we know the other 2 are green, or in a box, we know the other 2, I'm going to mark them green, and they are the 5 and 7. This parrot has both a 5 and a 7 on it, and that means that every parrot has a 5 and a 7 on it. And that means we can color these green, and they are 5 and 7. Now anywhere there's 2 greens, the rest in the row or in the column or in the 3 by 3 box where there are 2 greens, those are all yellows. And now we have 7 yellows. The last 2 are 9 in that column. Last 2 are 9 in that column. Last 2 are green. I said 9. The last 2 are green in that row, in this column, and in this row. And now we have our 16 or our 18 5s and 7s in rows, columns, and boxes. We can get rid of the yellow. We don't need that. These white dots on the 5 and 7s mean that the other cells have 4, 6, and 8. That means 1, 2, 3, 9 here. Now the 6 has to be here because that's either 4, 5, 6 or 6, 7, 8. This is not the 6, and this ratio on that swan has to be the same as that ratio on the swan. This cannot be a 6, 8 because there's no 3, 4 there. If this is a 6, 4, that could be a 2, 3, but then this is a 1, 9, and that's a chicken cell. A chicken cell can't be a 1-9, so this can't be a 1-9 ratio because 1-9 is a unique ratio. There's no other digits between 1 and 9 that can go with a 1 or a 9 and make a 1-9 ratio. So this is not a 6 at all. It's a 4-8 pair. This is the 6. This is a 1-2 ratio, and the only two in there of 1, 2, 3, 9 are the 1 and the 2. It means this is the 3-9 pair, and chickens are a 3-1 ratio, or a 1/3 fraction. So all chickens in the grid are either 1-3, 1-3, 3-9, or 2-6. 1, 2, 3, 6, 9. Swans are in a 1-2 ratio, so we have swans around the grid. There are 1, 2, 3, 4, 6, 8. Now these two swans are in rows where there is a chicken. And a chicken will have either a 2-6 or a 1-3 or a 3-9. So it has to have either a 3 or a 6. And the swans in the row cannot be a 3-6 pair. So those are 1, 2, 4, 8. This 3-9 sees up into that. That's not a 3-9. It's a 1, 2, 6. So this across a chicken is either the 3 or a 2 or a 6. It is not a 9. It is not a 1. That's 2, 3, or 6. So across the swan, that's either a 3-6 or a 1 or a 4, but it's not an 8 and it's not a 2. Now we're going to do flamingos, but there's 2 flamingos in the top row and 1 flamingo here. This flamingo has a 3 or a 9 on it with another digit. That could be a 1-2 if it was a 6 with a 3. It could be a 1-3 if it was a 1 or a 3 with the 3 or the 9. And then it can be a 2/3, 3/4. So first let's try putting a 6 there. 6-3 would mean that that's not a 2-6. I mean, that's not a 3-6, and that's a 2. 6 there puts a 2 there and a 6 there. The 2 there means that there's a 3 there, and this can't have a 2 or a 3 on it. So it's not a 1-2 or a 3-6. It is a 4-8. That 4-8 repeats with those 4-8s and the 4-8s that are highlighted now. There would be 4-8s in this box. There are 4 and an 8. This is a 6. 4, 6, 8. This is a 1-2 because it can't be a 3-6 or a 4-8. And now I still need 3 and 9 in that box, and they would have to go here and here, and that 3-9 prevents that. That's a long way of figuring out that this cannot be a 6-3 pair and not a 1-2 ratio. So it could be a 1-3 ratio except for this flamingo. That flamingo cannot take a 1-3 ratio. If that's a 1 and a 3, this is a 2-6, and that's a 2 or a 6. If that's a 3 or 9, this is a 2-6, and that's a 2 or a 6. If this is a 2-6, that is a 3 with a 1 or a 9, and this is a 3. That cannot be a 1-3 ratio. This cannot be a 1-3 ratio. It is either a 2 or 3 or a 3-4. And if it's a 2-3, that could be a 9, and that could be a 6. So that's a 2-4 or 6. These are 2, 3, 4, 6, 8, 9. They're either a 2-3, a 4-6, a 6-8, or a 6-9. This pair cannot have a 3. If that has a 3, then there's no 3 there and no 3 there, and that's all 2 6s. This is not a 3, and so it's not a 2. It is a 4-6, a 6-8, or a 6-9, so it's always a 6. No other 6s in the box. This is not a 2, it's a 1-3 or a 3-9. This is not a 3, it's a 2. That is a 6. This is not a 6, so it's not an 8 or a 9, it's a 2-3-4. That 4-8 takes the 4 out of there. This 2 comes down here. Those are not 2. The 2 there and the 2 there put a 2 over here. We'll use that in a minute. This cell can be a 1, 2, 3, 6, or 9. On a turkey, it's got to be the same ratio as that turkey and that turkey. So if this is a 9, that's either a 9-4 or a 9-8, then this has to be a 9-4, and that would have to be a 9 or a 4. Or that's a 9-8, and that would have to be a 9 or an 8, because 9-4 and 9-8 are unique ratios in the digit with pairs between 1 and 9. Not the 9. If that's a 1, then this is either a 1-4 or a 1-8. That means this is a 1-8 or a 1-4 or a 2-8. And any one of those needs a 1 or a 2, and that breaks that pair of 1-2. This is not a 1. Can this be a 2? If it's a 2-8, we just did that. That's a 1-to-4 ratio, and this can't be a 1-4 or a 2-8. But if this is a 2-4, then this is in a 1-to-2 ratio, like the swan, and the swan becomes a 4-8. This chicken then doesn't have a 2 on it. It becomes a 3 with a 1 or a 9. And then we've got a 2, 4, 8, 3. This is a 1 or a 6. But if that's a 1 or a 6, and this is a 2-4, this has to be a 3 or a 2. Well, it's not a 2. Those 2's break that. And it's not a 3 because the 3 there keeps that from being a 3. This is not a 2. This is a 3, 6, 4, 8 pair. And it can't be a... Can it be a 3-8 pair? No, a 3-8 pair would break in that column. Can it be a 6-4 pair, which is basically 2/3? These turkeys cannot be 2 and 3 because of that 2, but they could be a 3-4 ratio or 2/3 ratio if they were 4, 6, and 6, 9. But if they're 4, 6, and 6, 9, then there's a 6 here, a 6 there, and a 6 there. But we've already established that there's a 6 in one of those two cells, and a 6 there and a 6 there would break that. So this is not a 6-4 ratio. It's either a 3-4 or a 6-8, and that is the same ratio. That's called a 3-to-4 ratio. So all the turkeys become 3, 4, 6, 8. This 9 here puts a 9 somewhere there. This is a 6 by the sudoku with those. These 9s put a 9 up there. No 9 here. Wow, that's funny. This is a 3, 4, 6, 8 triple. That's not a 3. 3, 4, 6, 8 quadruple, I meant to say. There's no 3, 4, 6, or 8 in the column. That's not a 3. That is a 3. This is not a 3. This is not a 1, 9. We have a 3, 6 pair in that row. That takes the 6 out of there. The 3 out of there. This is the 4, 8. That's not a 4 or an 8. That 4 or 8 means that this can't be a 4, 8 pair. No 8 there. It could be a 2, 4 or a 1, 2, but it's always got a 2. That takes the 2 out of there, which takes the 6 out of there and makes that a 3. Now this is the 6, which goes with an 8 on a turkey. This is the 4. This is the 6, which goes with an 8 on a turkey. This is the 4. This is the 3, which goes with the 4 on a turkey. Over here, we don't have a 6. We have a 3 and a 4 on the turkey. There's the 3 and there's the 4. Now this 4 takes the 4 out of there and the 4 out of there, making flamingos a 2-3 ratio. So 2-3 equals 4 to 6 equals 6 to 9. This is a 3. That 3, 6 on a duck repeats here. This is a 1 and a 2. In this column, we have 1, 2, 9 left. And the doves can't have a 9 on them. So it's a 4, 1. And an 8, 2. And this is a 9. That makes this a 1 and that a 2. Because of that 2. This is not a 6 or a 2. It's a 1, 3, 9. I could do my 5s. That 4 is 1 away from 5. And this is a 7. This 4 needs a 2 or an 8, not a 1 or a 4. This is a 7. Can I do my 4s? I forget if it's time for the 4s. Okay. This 2 needs a 4. Or a 1. How do I fix that? This is a 1, 8 pair, so that's the 4. 1 goes here in the 8. This is the 9 in the column. Now I can do those 4s I was trying to do a minute ago. 4 goes here and here. Four goes here, so it goes there. This becomes a 2. Making that a 2 and a 1, a 3, and a 2. Two now goes there. This is the 3 with a 1 or a 9. That means that the owl, like the chicken, is a 1-3 ratio. This can't have a 2-6 on it. So this is a 1-3, 9 with the nut 3 in the middle. This is the 9 because of that 1. This is the 1 and the 9. This is the 1. Have I done my 3s? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Have I done my 9s? There and there. There. Have I done my 8s? 8. This is a 1 and a 1. That's a 6. There is a 6 there. That's a 2. Put a 2 there and a 1 there. And that's my puzzle. 19 minutes. I hope you enjoyed it. Be sure to check out, it was on Cracking the Cryptic, featured with Mark Goodliff solving it. He took an hour and 10 minutes. Well, his video was an hour and 10 minutes. The solution was a little shorter. Anyway, thanks for watching. Let me know what you liked and what you didn't like.